A 2,000 kilogram car uses a braking force of 12,000 newtons to stop in 5 seconds. What is the impulse that acts on the car? What is the change in momentum of the car? And what is the initial speed of the car? Well, let's solve number A first. We have a mass. We have a mass which is 2,000 kilograms. We have a force which is 12,000 newtons. We have a time which is 5 seconds. First thing that we're looking for is impulse equals question, and that unit is kilograms times meters per second. Now I'm simply going to use the impulse side of the equation and make it equal to force times time. Now let's replace numbers for letters. Impulse equals force is 12,000 and time is 5 seconds. When you do your math, I believe you calculate that 60,000 kilograms times meters per second. That's a solution to question A. Now, to solve for B, is actually pretty simple because impulse is exactly the same thing as the change in momentum. And so, because we know that impulse is 60,000, the change in momentum equals 60,000 kilograms times meters per second as well. Now on to question C. What is the initial speed of the car? Well, let's go back. We know that we have a change in momentum, or an impulse, of 60,000 kilograms times meters per second. We know mass equals 2,000 kilograms, and we know a velocity final equals 0 meters per second. And the reason that we know that is because it says that it comes to a stop right here. What are we looking for? We're looking for a velocity initial, and that's going to be in meters per second. And so I'm going to use change in momentum equals mass times velocity final minus velocity initial. If I replace numbers for letters, I get 60,000 equals 2,000 times velocity final here is 0 minus velocity initial, which I don't know what it is. Now I need to get this velocity initial all by itself on the right hand side. So I'm going to divide by 2,000. That allows me to cancel, and whatever I do to the right, I have to do to the left. So when I do my math, I get 30 equals 0 minus velocity initial. Now I can simplify this by saying 30 equals, and now I need to be careful, negative VI. In order to get that negative, I'll divide by a -1, so that cancels. And that means that my velocity initial equals -30 meters per second. Now you might ask, what does this mean? Velocity is a vector, and so if it has a negative sign, what does it mean? It's going backwards. So it was going backwards initially. 12,000 newtons were used to stop the car.